Hey everybody. So we're getting into 11.4 part 1 today, proving triangles are similar by AA, which stands for angle-angle similarity. Okay, so go ahead and get this title, get what angle-angle similarity is, and we'll get going. Okay, so 11.4 has two parts, and really it's broken down to where there are three different similarity theorems that we're going to be learning. Today we're just going to be learning one, in the following lesson we're going to be learning the other two. Okay, and yeah, today is called angle-angle similarity. Before I get into it, the purpose of this is to determine whether two triangles are similar to one another. Okay, it's a shortcut to figuring out if they're similar. All right, if you guys remember in the previous lesson, to say two triangles are similar, both of these things had to be true. All of their corresponding angles had to be congruent, and the ratio of their corresponding sides had to be equal. Okay, well, today, now we know a shortcut. If we can prove angle-angle similarity, then we can say that two triangles are similar, and we don't have to do all the other stuff, which is really nice. Okay, so what is angle-angle similarity? It's really simple. We'll read it. It says, if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Okay, that's all it takes is for the two similar triangles to have two pairs of corresponding angles that are congruent to one another. Okay, if this happens, we can say they're similar. Okay, and that's kind of, going to be the focus of today's lesson. So yeah, let's go ahead and get into the problem. Okay, so go ahead and copy this example, and we'll figure out if these two triangles are similar. Okay, so determine whether the triangles are similar. If they are, write a similarity statement. All right, so again, I'm now thinking, okay, we got our new theorem to figure out if these are similar. All I need to see if I have two pairs of corresponding angles congruent. Okay, taking a look at these two triangles, I can see right now I do have one pair of corresponding angles congruent. Okay, these are both 90-degree right angles. Okay, the question is do I have another pair of corresponding angles that are congruent? Okay, well, this one is saying that this angle here is 26 degrees. So I guess that's my first question is, can I figure out if this angle is 26 degrees? Okay, well, yeah, if you guys remember, whenever we have two angles of a triangle, we can subtract those from 180 to get our missing angle. So, if you want to show yourself in your notes, that's all we're going to do here. 180, I'm going to subtract 90, subtract 64, and see what I get. Let me do it real quick. Okay, and it looks like I'm getting 26. All right, so I just figured out that this is, in fact, 26 degrees right here. Okay, and since now I have another pair of corresponding angles that are congruent, I can say that yes, these triangles are similar. Okay, so we just figured it out. The answer, yes, they're congruent. Okay, if they're congruent, they want us to write a similarity statement. Just a little reminder, this is a similarity statement saying one triangle is similar to another. Remember that little squiggle line is shorthand for similar. All right. Just remember when you do this, you need to follow the same pattern on both triangles. Okay, so on this first triangle here, I'm gonna name this one CDE. Okay, so triangle CDE, and I'm going to say it's similar to this one. I need to follow that same pattern. I went from the angle that's 26 to the angle that's 90 to this angle that would be 64 if we did the math. We need to do the same thing here. So this one must be KGH. Okay, so that right there is just about as simple as these problems get. Again, we're just looking for two pairs of corresponding angles to be congruent. It's not always as easy as just, subtracting the other two angles from 180. Sometimes we get a little bit more elaborate problems. Okay, so that's what I want to look at here. Go ahead and copy these two examples and we'll try them together. Okay, so are the triangles similar? Why or why not? Okay, so take a look at number one. Okay, right now, it's pretty obvious. And by the way, the two triangles we're looking at are this triangle here, and then, the entire triangle here. Okay, so they kind of overlap one another. All right, but one thing that's pretty obvious is that they do have at least one pair of corresponding angles congruent. These are both 52-degree angles. Wonderful. The question is, can we find another pair of corresponding angles that are congruent? Okay, well, here's something I kind of want to show you. What if I were to draw these triangles separately? Okay, and you can do this with me if you'd like. It's not a bad idea to kind of show yourself in the notes. Okay, so that's going to be my triangle EAB. Here, let me make this black. Okay, and then let's draw the other triangle, the big one. Looks something like that. All right, and this big one we'd probably call DAC. Okay, the reason why I'm doing this is to kind of prove a point. These two triangles, they actually share an angle. If you guys notice, they both have angle A. I don't know what the measure of that angle is, but I do know whatever the measure of angle A is on this triangle, it's going to be the same measure on this triangle because it's literally the same angle. This angle A, it overlaps. Okay, so just to kind of show yourself in your notes, yeah, this angle would be congruent to this angle. Or actually, let's put two arcs through both of these since we put one arc through these. Okay, so do we have two pairs of corresponding angles that are congruent? Yes. So are these triangles similar? Yes. Okay, so they're similar. Why or why not? This is really us showing why, but let's just point out it's because of angle similarity. That's not how you spell it. There you go. Similarity. That's how you spell it, I think. Okay, so yeah, that's the idea. Some of these, to find that missing angle, it's going to take a little bit of work going, realizing, overlapping triangles have, a common angle. Let's take a look at number 2 and see what happens here. Okay, so this is going back to some stuff we haven't seen in a little while. Here's the first angle that I can say is congruent. I notice that, these are two straight lines crossing these angles here and here. Do you guys remember what those are called? Okay, vertical angles. Yeah, if you guys remember, rule of vertical angles is they are congruent. Okay, so there's one pair of corresponding angles congruent. Okay, can I figure out another pair? Okay, well, here's maybe hopefully something you notice. We have some parallel lines. All right, so let me kind of highlight those. Okay, here are my parallel lines. All right, and if you guys notice, either one of these, SU or TR, can be considered a transversal. I'm just going to point out one of them, SU. Okay, parallel lines and transversals, if you guys remember, very often gave us congruent angles, and that's exactly what's happening here. All right, this angle here, U, and this angle here, S, if you guys notice, are on alternate sides of the transversal. On the interior of the parallel lines, alternate interior angles are congruent. Okay, so we had to dig way back into our brains and remember, parallel lines, we're going to get some congruent angles. By the way, if I were to highlight this transversal right here, okay, angle R and angle T would also be congruent to one another. Okay, but I don't need to do that because I'm only looking for two pairs of corresponding angles that are congruent. Okay, so yeah, I have that. Are these two triangles considered similar? Yes, they are. Okay, and again, because of angle similarity. All right. So yeah, be careful. Sometimes you're not going to get all of the information you're looking for, and you're going to have to kind of dig a little deeper. Okay. So I'm going to have you guys go ahead and try out these two. It's the same directions. You don't need those again. Go ahead and copy these two and figure out whether or not these two triangles are similar. Okay, so number 1 is probably my favorite problem in this whole lesson here. It's kind of interesting. Okay, let's think about it. Okay, the first thing I notice on these triangles is that these corresponding angles are, as far as the symbols they're showing us, are not congruent. Okay, this one has one arc, this one has two arcs. Okay, this one, same thing. So right now, using the symbols that they're giving us, I would say, no, we cannot say these corresponding angles are congruent. Okay, but this is a kind of a weird problem. It's a tricky one. Can we actually figure out the measure of these angles? Okay, what I know, if I'm just looking at one of these triangles, all three angles are congruent. Okay, they're all the same measure, and I know that those angles add up to 180, right? So if I were to take 180 and divide it by 3, I would figure out what each of those angles is. Okay, and yeah, 180 divided by 3 gets me 60. Okay, so what I just figured out is that, oh, I can actually figure out the measure that these are all 60-degree angles. Okay, well, if that's the case for this triangle is no different. All three of these angles are congruent and they still add to 180 and they would still also be 60 degrees. Okay, so this is kind of a tricky problem. What's tricky about it is the fact that they use only one arc here and two arcs here. Really, they could probably just use one arc for all of these angles because, yeah, they are in fact all the same measure. Okay, so yeah, it took us digging a little bit again, but we just figured out that, okay, we do have two pairs of corresponding angles. We have more than two pairs of corresponding angles, but all we care about is two of them. So are these triangles similar on this one? Yes, they are. Okay, and the reason why, again, is because of angle similarity. Okay, but make sure you're showing, this information, on the last problems, make sure you're showing that, oh, parallel lines, transversal. That's really what's important. Okay, taking a look at number two. Let's try it out. So here's the first thing I think. I think right here, this is a right angle. If this is a 90-degree angle and these make a flat line, they add to 180, that means this is also a 90-degree angle. Okay, that's just where my brain goes first because that's usually always the case. Okay, so we do have one pair of corresponding angles congruent. Can we figure out another pair of corresponding angles? All right, well, here's the way these triangles sort of need to be looked at. We have this one in green, and then we have, this one here in blue. Okay, so yeah, let's focus on the green one here. I am just missing one angle. Okay, I have the other two. So this is kind of like our very first example. We can actually find this missing angle. Okay, if I take 180 and I subtract these two other angles, 90 and 32, I'm going to get that missing angle. So let's do it real quick. Okay, and I'm getting 58. Sorry, I'm out of room here, so I'm right here. Okay, so I just figured out that this right here is 58 degrees. Okay, and it looks like we also have another angle here that is 58 degrees. All right, so actually I'm going to put it inside of this. Okay, so it looks like we do now have two pairs of corresponding angles that are congruent. So are these triangles similar? Yes. Okay, and because of angle similarity. All right, so I gave you a lot of examples that the answer was yes. The answer is not always going to be yes, but what I really just wanted to show you is there's a lot of different ways we know how to find missing angles. Okay, we're going to have to dig back and recall those ways. Okay, all right. So the second part of this lesson is what do we do when we have similar triangles? What can we use? What can we find missing side lengths? Okay, so go ahead, get this example, and we'll try it out. Okay, so this is asking us to find P. Okay, here's the first big thing to realize on this problem. These are, in fact, similar triangles. Okay, and let's point out, we have vertical angles that are congruent. Okay, since these lines are parallel, and this is, a transversal, we can say really any of these other pair of corresponding angles are congruent, but let's just point out one pair. This angle is congruent to this. Okay, this problem, by the way, is just like this one where we had the parallel lines. Okay, so the first thing we got to realize is we do have similar triangles. Since we have similar triangles, if you guys remember, we can create a proportion to find the missing side lengths. Okay, all we need to do is make ratios of corresponding sides, set them equal, cross multiply, and we can figure out, this is what we did on our last lesson. All right, so let's go ahead and do it. So the first ratio I want to make is with this side length and its corresponding side on this triangle. The question is does it correspond to 12 or does it correspond to 10? Okay, well, if you guys notice, these triangles are kind of flip-flopped. All right, so we have to kind of look at our arcs, this, side lengths between 1 and 2 arcs, so it's going to correspond to this one between 1 and 2 arcs. Okay, so there is my first ratio I can make, and I'm always going to work left over right. So I'm going to do 10 over P for my first ratio. Okay, and I'm going to set it equal to the ratio of two other corresponding sides, and I'm going to use this side and its corresponding side, 24. Okay, and again, I'm going to work left over right, 12 over 24. Okay, and from here we can cross multiply and solve. But if you guys remember, this fraction, if we could ever reduce it, it's not a bad idea to do it, and then we end up with really easy numbers. This is a really simple fraction. We know this is going to reduce to a 1/2. So let's actually go one more step, and let's say, okay, 10 over p equals 1 over 2. Okay, and now when we go to cross multiply, our answer just kind of shows up in front of us. We get a 1 times p. Okay, 1 times p is a 1p, or p, and 2 times 10 gives us 20. And there it is. Okay, and I just want to remind you, if you don't reduce the fraction, that is still okay. You can still do your cross multiplication, get a 12p equals 240, divide both sides by 12, and you get 20. All right, so you can still do it this way, but if you can reduce really quickly, it's not a bad idea. Okay, so last one, I'm gonna have you guys try one just like this. Okay, go ahead, get this triangle here and find this missing side length, x, making a proportion. Okay, so if this is the side length, I am starting with, I guess before I even get ahead of myself, let's just point out real quick, these are in fact similar triangles. We have these congruent vertical angles. These parallel lines will give us congruent, I guess technically alternate interior angles, which we could say A and C are congruent, or we could say D and B are congruent. Okay, but just first thing to realize, okay, yes, they are similar. Okay, if they weren't similar, by the way, we wouldn't be able to make a proportion. We wouldn't be able to find this missing side length. Okay, but since they are, we can. So there is the side length I'm looking for. Okay, and I just want to point out its corresponding side on the other triangle is going to be this one. Okay, here's something that's a little tricky. I always say left over right, do left over right. Well, these are kind of not left and right. They're more like top and bottom. Okay, so normally when that's the case, I do top over bottom. Okay, but just remember, it doesn't matter what you pick as long as you stick with that pattern when you make both of your ratios. Okay, so I'm going to do top triangle over bottom triangle. I'm going to do x over 5. Okay, my other pair of corresponding sides are this one and this one. If I went top over bottom for that one, I need to go top over bottom for this one. I need to do this one as 4 over 3. Okay, I just want to point out, if you made your proportion as 5 over x equals 3 over 4, you're good. That's fine. You went bottom over top, bottom over top. That's okay. But what wouldn't work is if you did 5 over x equals 4 over 3. Okay, because that would be bottom over top, and then the other one would be top over bottom. You know what I mean? So just make sure you follow the same pattern. Okay, so yeah, here's the first thing I noticed. I can't reduce a 4 over 3. That's fine. I can just go ahead and cross multiply. So 3 times x is going to equal a 4 times 5. 3 times x is 3x. 4 times 5 is a 20. Looks like on this problem, we're actually going to get a fraction as an answer. That happens sometimes, just so you know. So dividing by 3 on both sides, 3 doesn't go into 20 evenly, and it also doesn't reduce. This stays as a 20 over 3. Here's the thing. I kind of want to actually understand what the length of this side is. So I'm going to go one more step. I'm going to divide those numbers in my calculator and actually get an answer that makes sense to me. 6.6 repeating is my answer. So x equals 6 point, and if it's 6 repeating, okay, if you guys remember in this class, we round 1 decimal place. Okay, so the question is does this stay as 6 or does it round up to a 7? Okay, well, it all depends on this number, right? If this is a 5 or more, it rounds this up, and it is a 5 or more. Okay, so we're actually going to round this 6.66 to a 6.7. So I guess I'll just go one more step right at 6.7. Okay, so yeah, this is old news right here. Making proportions was the last lesson, but the first thing we had to figure out was, are these in fact similar to one another? And we could figure that out using the angle-angle similarity. Okay, cool guys, so that's that. Our next lesson, we're going to be getting into the other two shortcuts to figure out if triangles are similar, and I'll see you then.